So, good morning, good evening, good afternoons, children. So, today we are going to start with the seventh lecture of this Is Matter Surround Us Pure? Okay, I think you have gone through the previous videos. I think you have understood it properly, and there was nothing difficult so far, right? Everything was so simple, and I would not say exactly simple, but yeah, there was not that much difficult, isn't it? Now, the thing is, today we so far we have learned so many things, right? How to separate out the constituent particles of a mixture. But in that process, there were so many times that I have told you about there are different types of different types of mixture. Like I think you remember, I have already told you the mixtures can be of two types, isn't it? One was homogeneous when when all the constituent particles are equally mixed. So if you take out a solution, if you just take out from like a mixture where all like from a portion of a mixture, and if you see that all the constituent particles are having an equal proportion all over the mixture, so it's like you have taken a beaker. Okay, in that beaker, let's consider that I have a solution, or I have a mixture of water and some sugar in it, right? So in this mixture, if I try to take out this mixture from here, or if I try to take out the mixture from here, if I mix it properly, then both the mixture would taste equal, isn't it? Because in both the mixtures, the quantity, the proportion of all the constituent components are almost the same, isn't it? So that's why we would say that this is a homogeneous mixture. This is a homogeneous mixture. Fine. Now, mixtures can be homogeneous like that only, or mixtures can be heterogeneous as well. Now, what is heterogeneous? Now, if you think about a mixture, if you think about a mixture of water, and let's just consider there are some particles. Let's consider that there are some sand particles over there. Okay, fine. So they are the sand particles. So if I consider this mixture, then here, if you try to take out a solution from here, and if you try to take out the mixture from here, both the beaker A and B won't give you the same taste, isn't it? So depending on whether you like drinking or eating sand or not, I don't know. But if you like eating sand, then B would be very tasteful to you, right? And like I mean tasty to you, and A would be tasteless, isn't it? So that is the thing over here. So you would have different tastes, isn't it? Think about it. When you are I think you all like tea, okay? Because I like it so much. Now when I drink tea, okay, I just add some sugar in it. I think everyone of you do the same thing, and I just add some sugar in it. Have you ever noticed that after, when you're just about to finish your tea, you'd be able to see that some sugar particles are there at the bottom, and the other tea at the bottom tastes a little bit sweeter than the rest of the tea, isn't it? So that part is my favorite. The thing is, that is a heterogeneous mixture there. If you do not stir the tea properly, that is a heterogeneous mixture. That is why the taste is different in two places. Okay, so that is called a heterogeneous mixture. Now, excuse me. Now, this homogeneous mixture, we can also call it solution. We can also call it a solution. Okay, and this heterogeneous mixture, they are again divided into two parts. Okay. One is colloid. Another one is suspension, isn't it? So far, you have heard about all these things so many times, isn't it? The colloid, the solution, the suspension, all of them. So today we are just going to learn about these things only. So we call it solution or true solution. You can also say true solution there. Okay. So we can also say true solution. Okay. And colloid and suspension. So if someone asks you what is the solution, you would say solution is a homogeneous mixture. Okay, clear? So you can see today we are going to learn about the suspension, the colloidal solution, the difference in solution, suspension, colloidal solution. So I think you got the thing that we are going to learn today. Clear? Now, the first thing that comes is suspension, properties, and example. Now, what is a suspension? If you just look at this picture over here, you can see this is nothing but a muddy water, isn't it? This is a picture of muddy water. Right? Now, in this thing, if you just keep it there, if you just keep it there for about a couple of minutes, what would happen? So if that is the water that contains some mud particles in it. So let's consider that these are the mud particles inside the water. Fine. These are the mud particles inside the water. So if you just keep it there for a couple of minutes, then what would happen? Then definitely that mud particle would settle down, isn't it? Can you tell me why are they settling down? What is the reason behind them to get settled down? Why are they settling down at the bottom of the beaker? The answer is pretty simple. For suspension, the particle size is big enough that it faces an inward pull due to gravity only. So as its mass is high, for that reason, what is happening? It is facing an inward pull towards the bottom of the beaker due to the gravity only. Okay, it faces more amount of gravity. And as a result, what is happening? They are sedimenting, and we call it sedimentation, isn't it? I think now you can remember that. We have heard about it earlier. Tell me, isn't it? Don't you remember like sedimentation and decantation? Can you tell me what was the name of that liquid which is there over here? These are the sediment. Okay, the process of taking out the sedimentation, the liquid and the sedimented particles is called decantation. And what is the name of this liquid which is clear the top of the beaker? Supernated liquid, isn't it? Did you get it? We call it supernated liquid. Fine. So that was the thing. I think you got about suspension. So suspension is a thing like that is having the particle size, very big particle size. Okay, maybe the particle size is greater than 1 micrometer, or we can say 10 to the power minus 6 meter. If the particle size is greater than that, then what would happen? They feel a very much inward pull, and they try to settle down towards the bottom of the beaker. Okay, and as a result, we can see that they just separate out. You can see that here, the bottom of the beaker, this is the mud over there. Okay, and this is the supernated liquid. Fine, this is the supernated liquid, which is water only. Clear? So that was all about this suspension. So you can see it over here as well. Okay, so there you can see this thing is entirely, there is a sedimentation there as well. Fine. Now, what are they saying over here? Is suspension is a heterogeneous mixture. So as I told you earlier, I have already told you that suspension is a heterogeneous mixture. Now let's understand why is it a heterogeneous mixture. Okay, first just go through it. Okay, after that we would explain all these things. Okay, mixture in which the small particles are spread throughout a liquid without dissolving in it. For example, chalk and water, muddy water, sand and water, flour and water. Fine. So all of them are examples of suspensions. Now, as I told you, like, why do we call them heterogeneous? Again, you got it. We got it like, if we take the solution from here and if we take the solution from here, I would get different tastes because the component have different constituent particles. They have different compositions, isn't it? Because of the compositions are uneven. We are going to call it heterogeneous. Fine. Because of the uneven composition, we call it an heterogeneous mixture. Clear? Now we would go to the next part, which is a colloidal solution. Now, what is a colloidal solution? So the first thing you need to know that colloidal solution is another heterogeneous solution. Okay, heterogeneous solution. Now, for colloidal solution, the particle size is near about 10 to the power minus 9 meter to 10 to the power minus 6 meter. This is the range, okay? This is the range. Straight from it. Yeah. So this is the range of this colloidal particles. So they remain in this range, and for that reason, what happens is they are not like the sediment, like not like the suspensions. So what happens for them is, if this is a beaker full of colloidal solution, so I should say colloidal mixture, let's just say that there are some colloidal particles like this. So they are not big enough. They are not big enough to settle down. They are not big enough to settle down. So what would happen? They would be, floating in the solvent. They would be floating in the solvent throughout. They are not big enough. They don't have enough mass to get settled down like suspension. So they would be floating. The particles would be floating in the solution. Okay. So for that reason, there are two phases because the particles are solid. The particles are solid and the solution there is in liquid phase. So there is a phase difference over there. Okay. So for that reason, this mixture is called homogeneous. And this is more like, more like translucent. I have already told you about this colloidal solutions. These are mainly translucent in nature. Okay. So you can see there are so many pictures over here, like the milk is a colloidal solution, like fog is a colloidal mixture. So you can see like this is the thing. It is a little bit translucent, isn't it? Detergents are colloids, are foam. We can also say foams are colloid. You can see here there are the foams. Okay. Apart from that, you can say like gels are colloid, bloods are colloid. So remember, we were separating out bloods with the help of centrifugation. And at that moment, I told you blood is called a colloidal solution. The colloidal solutions are the solutions where, like mixtures, where the particle size is near about 1 nanometer to 1 micrometer. Okay. So that is the thing about the colloidal solution. So if the particles are suspended throughout the solution, they won't settle down. They would be there only. Okay. They would be there floating in the solution. Fine. This is about the colloidal solution. So you can see there are nothing but mixture in which substances are regularly suspended in the fluid. So if you just keep this colloidal solution for a moment or two, for a minute or two, it won't get settled down. Okay. That is the speciality about it. So the colloidal solution, so we can also say You can say also say it like that. Colloidal solution are stable. So colloidal solutions are stable. They won't settle down. They are very much stable on the floating medium. Okay. And for colloidal solution, we do not use this solvent and solute things. We use rather, you already know about it, right? Dispersed phase and dispersion medium. Now, what is dispersed phase and what is dispersion medium? Let me tell you that whatever we call solute for solution, whatever we call solute is dispersed phase in colloidal solution. And in dispersion medium, what is dispersion medium? Whatever we call solvent for normal solution is the dispersion medium for colloidal solution. Fine. So that is how it takes its role. Now, depending on the solute and the solvent, different types of dispersed phase and dispersion medium, there are so many different varieties of colloidal solution. So colloidal solutions can be like salts, they can be like gels, they can be like aerosols, okay, they can be like foams, okay. There are so many other things. Okay, the salts are of two types, solid salts and liquid salts. Okay, so there are so many variety of colloidal solution that you would be able to see. Okay, depending on the different dispersed phase and dispersion medium. So dispersed phase can be solid, liquid, gas, all these three things, and dispersion medium can also be solid, liquid, gas. So depending on the combination that can happen over there, we can differentiate different types of colloidal solution. Okay, fine. Can we move on? Are we understanding? Are we understanding the topic? Can I say that we are understanding it up to 80%? We can say it, right? So you just revise the entire thing after I'm done. Okay, just look at this entire thing for a moment. Okay, it would take near about 5 minutes, okay, to revise all these things. So you just take 5 minutes and revise everything that I have taught you today. Okay, after this video is done, after that you'd be able to see that this would be converted into 95%. Now if you just keep on revising, then it would be going closer to 100%. Okay, now difference in solution, suspension, and colloids. So right now in this GIF, you can see this thing over here. This thing over here is a solution. So what do we understand by the word solution? Whenever we see the word solution, the thing that comes in our mind is solution is a homogeneous mixture, isn't it? So that should be transparent. That should be transparent. Solution should be transparent for the true solutions. Okay, so you can see that is a transparent, and this is a laser light. Okay, this is a laser light, and you can see it. There is a light goes like this through it. Okay, now for solution, what is happening in this picture? What is happening for the solutions? So for solution, this I just try to draw 3 beakers over here. Let's just consider one of them is containing salt water. Okay, another beaker over here, let's just say it is containing milk water. Okay, and there is another solution over there that is containing mud plus water. Fine. Now, needless to say that this one is a solution. Okay. This one is a colloid, right? And this mud water is called suspension, isn't it? It is called suspension. Fine. Now, what would happen? So for solution, the particle size is so small that you cannot see the particles. There will be no such problem with that. But for colloidal mixture, what would happen? For colloids, the particle size are big, little bit. So if you just pass a light through it, then what can happen? So if this is a particle, if a light, if a red light is coming to it, and if this particle is big enough, then if it comes in the way of this red light, then what can happen? This red light can hit it and it can get scattered in all the direction. Possibilities are there, right? So if you are watching it from here, and if this light falls onto your eyes, then you start see the entire thing glowing, isn't it? Right? You started seeing glowing. It is glowing. You'd be able to see that. Now, this is what happens. This is what happens. You can see this picture over here. What is happening here? At first, it was a normal solution like this. Now he is mixing some milk with it. And after that, he's just mixing it. Then what is happening? You can see the pathway of the laser is visible there, isn't it? So just look at it again. When he mixes some amount of milk over there and dissolve it, then you'd be able to see the pathway of this light. So actually what happening is the light is going like this. And whatever comes in its way, whatever comes in its way, whatever the particle is that comes in its way, what is it doing? It is just scattering the light like this. All the particles are doing the same thing. Okay, so for that reason, all of these particles have started glowing, and we can see the pathway through which the light was going. All the particles that comes in the way, all of them started glowing, isn't it? So due to this scattering, of light, all the particles have started glowing. And for that reason only, as they have started glowing, for that reason only, you can see the entire pathway through which the light is going. Like you can see it like that. This is nothing but the particles, those who are there, they are just scattering the light and it is falling into our eyes. For that reason only, we can see it glowing. And we can see the entire pathway of the light. We have seen the same thing, isn't it? If we have seen the same thing, if you just turn on your torch and just point it toward the sky, isn't it? You can see the pathway of the light going. So in the sky, what happens is there are so many dust particles. There are so many, moisture in the sky. Okay, in our atmosphere, so many particles in the atmosphere, smoke, and so many things over there. So when you are pointing the torch towards it, so every particle is scattering the light to some extent, and you can see the entire pathway of the light. Fine. So this is what happens. We call this Tyndall effect. This effect is shown by both colloids and suspension. But for suspension, what happens is this effect is not that much important, significant, because it stays for a couple of minutes only. When all these particles settle downwards, if you just turn on the light, they won't be able to scatter it anymore, because they have all settled downwards. To scatter the light, they needed to, float on the surface. Only then they can have, scatter the light. As they are not stable enough, as this solution, this mixture is unstable. For that reason, what is happening? It is scattering the light for few minutes only. Okay, unless and until it is not sedimenting down. Clear? We call it Tyndall effect. Fine. Now let's understand the entire thing about the solution, suspension, and the colloid. I think you have understood all of it. So let's watch a video. You like football as well, right? You didn't see the entire guy standing over here. So he's adding sugar in the first beaker. I think everything is written over there, isn't it? Wants to make some lemon juice, I guess. Now he's adding chalk powder in the second beaker. Oh, it is written as well, isn't it? And milk in the third beaker. The third beaker is the colloidal solution, isn't it? The second is the suspension. So if you just direct the beam through a true solution, you will not be able to see anything, right? The particles of sugar have completely disappeared in the mixture. Okay. Such thing is called homogeneous mixture. I think you got this thing, right? Uniform throughout. Yeah, homo. So in homogeneous mixture, I think I have told you earlier as well. In the homogeneous mixture, consisting of two syllables, okay? So here the homo word means same, isn't it? And this genius is coming from the word genity, from where we call it the concentration. Okay, when all the constituent have same concentration, we call it homogeneous solution. They cannot scatter any light, unable to see the path of the light. So that is called the Tyndall effect. Okay, for solution, you cannot see the Tyndall effect because that is 1 nanometer. So 1 nanometer is nothing but 10 to the power minus 9. I think you remember that. 10 to the power minus 9 meter. That was the particle size for true solution, isn't it? For solution. The mixture is a heterogeneous mixture. You can see chalk powder in it. Heterogeneous means hetero means different. Hetero stands for different. So the water is big enough to scatter the light passing through it. So you can see the light. You would be able to see the pathway of the light. Like you can see it. right now. Such mixtures are called the suspension. They can scatter the light, which is called Tyndall effect, larger than 1000 nanometer, which is 10 to the power minus 6. This is for suspension. However, the colloidal solutions are equally settled down, and after some time, they stop showing Tyndall effect. Fine. Let's wait for a moment. Yeah. So for that was for the suspension, right? However, these particles are eventually settled down. So after some time, Tyndall effect may not be observed in suspension. That thing we have already discussed, right? Third mixture, it was about the colloidal solution. The part is visible, you can see over there as well, right? The mixture appears to be homogeneous. Observed under highly powered microscope, it is actually heterogeneous. Okay, so it might be looking like homogeneous, but it's a heterogeneous solution. Such mixtures is called colloid. Size of the particle is 1 nanometer to 10 to the so that thing -9 to 10 to the minus 6. So they never settle down. They are very much stable. Okay, and this shows the Tyndall effect permanently. Still thinking about the ball. Fine. You understood it? There was nothing new, right? We have already discussed about all of them. Now, what is a colloid and a suspension? We have already read about it properly. So you can see the solutions over there. Okay. You can see them. So in case of a solution, what is happening? In case of a solution, you can see the particles are, that was actually a GIF. Okay. Should be playing. Let me just look into it. Just give me a moment. Yeah, you can see it over here. So the solution particles, they are very much unstable. They are randomly moving, right? For suspension, the particles are bigger. You can see the difference. So the particles are very small over here. And they are randomly moving, okay? They are random as well. Okay, so you can see the motion of these particles over here. There is a name of this motion as well. We call it Brownian motion. Okay, this motion of these particles, this random motion, like here and there, they're moving like here and there, right? So that is called Brownian motion. So there was a scientist called Robert Brown who saw this motion for the first time with pollen grains. Okay, so its motion was experienced by pollen grains, and for that reason we call it a Brownian motion, because all the fluids, so Brownian motion is seen for all the fluids, all types of fluids. Okay, that's why it is very famous. Fluids means, look, fluids, whenever you see this, fluids mean both liquids and the gases. So in both the cases, you see this Brownian motion. So you can see all the particles are moving randomly. Okay. So that is for solution. And the suspension, you can see the particles are very much slow. Why are they slow? Because they have larger size. So you can see the constituent particles having larger size. They are very much slow. Their Brownian movement is very much, sloth-like, and they just want to settle down. Okay, settle downwards. And for colloidal solution, this is the colloid. So for colloidal solution, you can see the particles is medium. Okay, as I already told you, this is of 10 to the power minus 9 meter. Here the particle size for suspension is greater than 10 to the power minus 6 meter, and here it is from 1 nanometer to 1 micrometer. So we can also say like this, 10 to the power minus 9 to 10 to the power minus 6. Goes on like that only. Fine. These are the particle sizes. So that was about the colloidal solution. Fine. So now what is the colloid and suspension? So how to write the answer? Although heterogeneous mixture is of two substances like suspension and colloids involve the particles form 1 to 1000 nanometer that do not separate upon standing and cannot be separated by filtration. The particles in a colloid lands in the size between those in solution and suspension and maybe solid, liquid, or gas. So the thing they're trying to tell you over here is for colloid. So colloidal solutions can be of solid, of liquid, of gases. So what I mean to say is the colloidal solutions, there are how many types of colloidal solutions can be there. So solid colloidal solutions can be there. Okay. Solid, liquid, I'm just writing S and L, colloidal solution can be there. Solid plus gas colloidal solutions can be there. Liquid plus liquid colloidal solution can be there. Liquid plus gas colloidal solutions can be there. Okay. And what else? But you know what? Gas colloidal solution cannot happen. Gas cannot form colloids. Why? Because when two gas particles are there, let's say that there are gas particles A and gas particles B. If I just let them mix, then what would happen? They would each and every time, two gaseous substances always makes homogeneous solution. Always. They never makes heterogeneous. So two gas particles always makes solutions. Fine. So there can be so many different types of colloids that are I'm trying to tell you, and the particle size you already know. And so from there you can differentiate between a solution and a suspension colloids. Okay. Now, so is smoke a colloid or suspension? Think about it. So smoke, what does it contains actually? So I think you have seen like from the chimneys, the smoke comes out, right? From the different types of chimneys, from the industrial belts, right? In the industrial belts. So the smoke comes out. So what are these smokes actually? Are they like solutions? Are they colloids or they or the suspensions? What are they? So smokes are actually having gas and solid mixture of colloid. So colloid where the dispersed, so they have the dispersed phase and dispersion medium, isn't it? For colloidal solutions, phase and dispersion medium, isn't it? So in case of smoke, the dispersion medium is gas and the dispersed phase is solid. Okay, and definitely this is a colloid. Okay, smoke is a colloid, fog is a colloid. Definitely smog would also be a colloid. Fine. Now that was so. In case of fog, you tell me, in case of fog, what would be the dispersed phase and what would be the dispersion medium? Dispersed phase and the dispersion medium. For fog, when you just walk through a fog, what is the thing that happens? When you walk through a fog, your shirt and whatever like you are wearing, it becomes wet, isn't it? So in case of smoke, you cannot feel that. Everything is just remains dry because that is solid in there and gas in there. But when you walk through a fog, you feel your shirt is wet. Why is that? Then definitely here the dispersion medium is again gas because that is floating. That is going to be gas only. But in case of fog, the dispersed phase is not solid, it is liquid. Fine. So that is the point of here. Let's see. So smoke is a colloid, 100% colloid. Colloid is a special solution consisting of tiny particles remain suspended significant amount of time. Fine. Got everything for this class. I think there is no such problem that you have faced all over. So if you have any doubt, what you have to do, tell me. You know better than me, right? I've already told you a couple of times, and definitely now you can also you also know what to do. So you just write it on the forum, and definitely we would get back to you. So I think you are enjoying the sessions, and you know what? I am enjoying the time with you. Okay, so that's it for today. And definitely we are going to meet in the next class. And you just keep on studying, keep on learning from Ask IITians. Bye, everyone. Good night, good evening, good morning, whatever. Okay, bye.